Hi, I'm Joseph. Now I'm talking about subthreshold leakage current in MOSFET. When we consider MOSFET in P substrate, N substrate, two N regions are at a distance. When we bring together, here accumulation becomes so much, and channel, here it is, you consider this as channel, accumulation becomes so much. This becomes a thin P region. This structure resembles bipolar junction transistor. Okay, in bipolar junction transistor, electrons from, if say is emitter, base and say collector, if base is significantly smaller, the electrons come to the base, and as the region is very much smaller, these electrons can go from base to collector also. The concentration drop will look like a linear region. That is, when it is on, drift current dominates the transistor current. When it is off, diffusion current dominates. The thing is, if it is on, the effect of drift current will be in a linear, but when it is off, the diffusion current will be significantly having more penalty. It rises more, that causes more problem. This causes more problem than this one, than the on side. Here, so the current off is equals to I naught into E of Vgs minus Vt by N phi t. Okay, N is the non-ideality factor. Non-ideality factor is typically N is equals to 1.5 for planar region. For FinFET, it can be brought down. Okay, that means in present technology. Now, into 1 minus e power minus Vds by phi t into 1 plus lambda Vds. Okay, I of is equals to I not the same expression. Here the Vgs affects leakage correction, so is Vth. Both affects the leakage current. When you see a graph, certain part drain current doesn't rise, but at certain voltage, the threshold voltage, the current rises. Still, when it reaches threshold voltage, current rises. This is abrupt switch behavior. This is like switch like behavior. For this we consider subthreshold slope. Here, when we consider log of ID across VDS, initially the current itself is very high, and then it reaches threshold. When it passes till the threshold, it rises till the threshold voltage, and then it is linear. Here in some threshold slope, the equation the current is in nanoamperes. Okay, that's a non-linear scale. Now when we apply log 10d, we take log 10 is equals to log 10 of id is equals to log 10 of I naught plus Vgs minus Vt log 10 of phi. This is the equation. When we differentiate with respect to Vgs, what happens is, because everything becomes nullified, everything becomes constant and nullified, this is the equation we get. Okay, so for slope is equals to 1 by d log of 10 id by dvgs is equals to n phi t by log 10 e is equals to log e of 10 n phi t. Unit of subthreshold slope, that is s is equals to log 10 e, as that n value is what, 1.5, and this phi t value, what is, it is 25 millivolts at room temperature. By calculation it gives around 90 millivolts per decade. So this is a value that we need to reduce gate voltage by 90 millivolts per decade to drop the current by the factor of 10. This determines how good the transistor, this number determines how good the transistor switch is. Okay, if we further reduce the VGS, I mean beyond 0, it reaches a point that is called GIDL, that is gate induced drain leakage. The current also drops. where VGS is equal to, it is till minus 0.3 volts. After minus 0.3 volts VGS, the current rises. So subthreshold leakage, here the current reduces only till certain VGS point. After this current increases. Okay, if VGS is beyond 0, then current becomes further, and even further non-ideality comes in. We need to consider non-ideality, and again the current rises. Okay, this is about subthreshold leakage. Simply is that it is only to certain VGS value beyond 0 we can reduce current. After that, for sure current will increase. That's another factor, but this is for now. And this is for planar regions. 90 millivolts per decade is planar regions for planar technology. For FinFET technology, this is further reduced to minus 60 millivolts per decade for planar regions. We need to consider all this is due to consideration of certain natures. Okay, this non-infidelity, for practical purposes this is the value. Okay, thank you.